So a recurrence relation for a sequence A0, A1, AN is just an equation that relates AN to its predecessors. When we say predecessors, it means the previous value. So if AN is here, then all values before AN will be predecessors. So starting from A0, A1 up to AN minus 1. Here are some examples on some functions that we can describe them recursively. Let me go over them quickly. So our first example will be the power of 2. So examples, the first one, we have AN, and I'm going to call it AN is equal to 2N, okay? And if I go back to the slide, so we have AN, it starts from, and we can find it from where does it start. Because if you see here, it depends on what you want your sequence. Suppose your sequence you wanted 1. So suppose that AN, you wanted 1, 2, 4, 8, 16, and etc. So this is what you want for your sequence. And by the way, you can start from 2. If n is equal to 1, if n greater than or equal to 1, then you will start from 2, etc. But if you start from 0, you are going to get this. So how to describe it recursively? On one side, ask yourself, if this is AN, then what is AN? What is the equation for AN minus 1? The answer is AN minus 1 is equal to the power n minus 1, and you can find it easily from here. You remove n and put n minus 1. So we will start from AN equal to 2n, and this is equal to 2 multiplied by 2 n minus 1, and since n minus 1 is equal to an minus 1, so we will have 2 multiplied by an minus 1. Then we can say that an is equal to twice the previous value. But what will be the initial value? And are we going to give it 0 or 1 and etc.? So we are going to give it as 0 because anything raised to power 0 is 1. And in here we will start from 1. So this is how it is described recursively. If you go to the next example, it is for factorial. Now for factorial, the second example, so number 2, we have number 2. If we label the factorial as an, so what will be an minus 1? It will be n minus 1 factorial. So we will start by defining an, since an is equal to n factorial, and we all know that n factorial is equal to n multiplied by n minus 1 factorial. But n minus 1 factorial is the value of an minus 1. So you can simply remove n minus 1 and replace it by n minus 1. So this is the value of an. The question is, what will be the initial value? So we will start from 1. We assume the first, because when you multiply, or if you want to find factorial for any value, the last value is 1. So we will write it in reverse order, 1 times 2 times 3 up to n. So here we will start from 2, and this is the recurrence relation. Maybe I can cloud it. So this is the recurrence relation for the factorial, and this is the recurrence relation for the power n. The third example is a very famous sequence which is called Fibonacci sequence. So I will copy it, take it to our notebook. So how to describe it by numbers? We will start from 0, so index 0 and index 1. So we will have f1, and we will have f2, f0, f1, f2, f3, f4, and we continue. The first two values are equal to 1. And it says that for any number in the sequence, you take the previous values, immediately previous values, and you add them together. So the previous value for f2 will be 1 plus 1, so the answer will be 2. The previous values for f3 will be f1 and f2. When you add them, you get to 3. The previous values for f4 will be f2 and f3. When you add them, you get 5, you will get 8, and you will get 13, you will get 21, and it continues. What we will do next is we are going to show you how to find a solution for recurrence relations. There are many methods. Some of them depends on understanding some math basics. So I will go over some of the math basics, and then we will discuss the methods for finding a solution to a recurrence relation.